Alright, this is part 2 of the VSEPR theory notes, and we're going to take a look at the rules one more time just to help refresh your memory. Alright, so when we talk about VSEPR, and you talk about that three-dimensional shape, the first thing you want to do is make sure you have a correctly drawn Lewis structure. Then you're going to count your valence electron pairs around the central atom. Alright, make sure you count how many are bonded and how many are lone pairs, and then you're going to use your VSEPR chart to determine what is the shape of the molecule going to be. Alright, so one of the common questions is when we talk about coordination numbers 5 and 6, or 5 or 6 groups around the central atom, is what happens when we don't have enough valence electrons? If this happens when you draw your Lewis structure and you don't have enough, what you're going to do is you're just simply going to add lone pairs. Remember, LP stands for lone pairs. You're just going to add them around the central atom. Alright, and you are going to keep adding them until you have the number that you need. So you just keep adding. So say if your molecule has 30 valence electrons, you only have 26, you're going to add 2 sets of lone pairs to your central atom to make sure you get the correct amount. And then you're going to check your VSEPR chart. Alright, so here's the chart we're going to look for today with coordination number 5 and 6. Alright, with 5, we have the shapes called trigonal bipyramidal, seesaw, the T-shaped, and linear. After this, I'm going to show just a quick little video of some of the different shapes using the model kits that we have in class. Then for coordination number 6, we have octahedral, square pyramidal, and square planar. Alright, let's take a look at things with 5 groups around the central atom. So when we draw this Lewis structure, we're going to have a P in the center. We're going to have 5 fluorines around the phosphorus. Now you're probably thinking, well, how can that be? I thought you said everything follows the octet rule. Yes, that's true. Everything does want 8 electrons around itself, but when you take a look at the phosphorus right here, 2, 4, 6, 8, 10, it has 10 electrons. Now this is because, especially sulfur and phosphorus, they can expand the octet. That's what it's called. That means they can actually have some electrons go into higher orbitals. Okay, so that they can actually have a couple more electrons than other atoms. All right, so when you draw your Lewis structure, all right, it looks like this, and when it should have 40 valence electrons. So we add these up, you should have 40. You have 5 from here plus 7 times 5. That gives me the 40. And when I count this up, I have 40 altogether. Now let's go ahead and let's check our atoms. So we have 1, 2, 3, 4, 5 groups around the central atom. Out of those 5 have a bond. 0 are lone pairs around the phosphorus. So let's go ahead and let's take a look at our chart and see what this is going to be. So if we have 5 bonds, 0 lone pairs, we're going to be trigonal bipyramidal. So let's go ahead and let's write down our shape. Trigonal bipyramidal. And here is what the molecule looks like if you were to have model kits. So it kind of looks like this right here, where you have your central atom and you have your 5 bonding atoms to it. And it's a trigonal pyramidal because it's triangular shaped, and it's bipyramidal because there's a pyramid on top and a pyramid on the bottom. If we were to fill in the faces here, it would kind of look like 2 pyramids, one on top of each other. All right, let's take a look at a second example. For example number 2, you have Si4. All right, so we are going to have the sulfur as our central atom. So let's go ahead and start our Lewis structure. So we put the sulfur, and let's go ahead and let's bond the 4 iodines to my center. So we have our iodines, and we count up our total number of valence electrons. We're supposed to have 34, so I'm going to make sure we have 34. So I'm going to go ahead and fill in my electrons. All right, everything has 8 so far, and this needs 8, so we're all good. So we have 6 dots around everything. Make sure everything has 8 valence electrons. And sulfur is 2, 4, 6, 8. But when I count this up, I only have 32. So when this happens, you're just simply going to add an extra lone pair around the central atom. We did not have enough. We had 32. I added lone pairs around the sulfur. Now I have my correct number of 34. So all I do is count the groups around the central atom. 1, 2, 3, 4. And don't forget about that one. That's 5. So we have 5 things. for our groups, for our bonds, one is a lone pair. So let's go ahead and let's take a look at our VSEPR chart and see what that's going to be. So if we have 4 bonds, 1 lone pair, that's actually the seesaw shape. Okay, and I'm going to show you again with the model kit how that is going to be the seesaw. So our shape is seesaw. Alright, and if we take a look at this right here, you can kind of see what it would look like right here. Alright, if I were to rotate this just a little bit, you can kind of see, if you kind of rock it back and forth, kind of look like a seesaw going back and forth. And that's what the seesaw does. And if I show you the model kit in just a moment, that's exactly what it's going to do. Alright, let's take a look at example 3. For example 3, we have BrCl3. Bromine is going to be in the center, and the 3 chlorines are going to be bonded to the bromine. And we make sure everything has 8 valence electrons. You need a lone pair. You only need 6. This needs 6 more electrons. That also needs 6 more electrons. Let me make this bond just a little bit longer so it looks a little bit better. Okay, now let's take a look at what we are supposed to have. We are supposed to have 28 valence electrons, because 7 from here plus 7 times 3 is 21. That gives me 28 valence electrons. But when I count this up, I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. I don't have enough valence electrons. So what we are going to do is just simply add an extra lone pair around the central atom. All right, let's go ahead and let's count the groups up. And we say we have 1, 2, 3, 4, 5. So we still have 5 groups. Now, out of those 5, 3 are bonding, 1, 2, and 3, and we have 2 lone pairs. So let's go ahead and let's take a look at the table. So we have 3 bonding, 2 lone pairs, and this right here is going to be my shape. It's going to be T-shaped. All right, so that is what my shape is going to be. T-shape. And we take a look at the drawing right here, and it looks like a T with 2 lone pairs at the top. Alright, so that is the T-shape with coordination number 5. Alright, for example 4, we have an I3 ion with a -1 charge. Alright, so let's take a look at how many valence electrons does it have. So I have 7, this is iodines in group 7, times 3, so that gets 21. Now remember, if you have an odd number, you can't do them. But remember this electron right here, since this is -1 charge, you have to add 1 to the total number of valence electrons. So now I have 22 valence electrons. So I'm going to go ahead and start bonding my 3 iodines together. And let's go ahead and make sure everything has 8 valence electrons. So this iodine will need 6. This iodine will need 6 as well. This iodine only needs 4. So let's go ahead and let's start counting up our valence electrons. Alright, so I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. I don't have enough. I only have 20. So what I'm going to do is I'm just going to add a lone pair to my central atom. So now when I count my groups, I have 2 bonding, 1, 2, 3 lone pairs. So I have 5 groups, 2 are bonding, 3 lone pairs, and this is going to be a linear shape. Notice right here that everything is in a line with the 3 lone pairs around the central atom. Alright, so let's go ahead and write down the linear, and let's take a look at what the picture looks like. So this is the linear shape right here. Alright, and it should look very, very similar to my Lewis structure, and it actually does, except this is just a 3-dimensional representation right there. Alright, let's take a look at 6 groups around the central atom. Alright, so for this one, we are going to put my sulfur in the center, and we are going to bond 6 bromines around it. So we're going to put the bromines around the central atom, and let's go ahead and let's figure out how many valence electrons I'm supposed to have. There's 6 right here, plus 7 times 6, so that's 42 plus 6, so I'm supposed to have 48 valence electrons. Each bromine only needs 6 dots, so I'm going to go ahead and pause the video, fill in my valence electrons, and then come back. Okay, I'm back, and I completed my Lewis structure. Now remember, the only reason why we are able to do this is because some atoms can actually expand the octet, and they can actually have more valence electrons than the octet rule states, 8. So sulfur is 2, 4, 6, 8, 12. It has 12 valence electrons around here, and let's go ahead and count up our numbers. So we have 8 times 1, 2, 3, 4, 5, 6 around here, so that gives me 48. So this is a correctly drawn Lewis structure. So when we talk about our groups, okay, we say there is 1, 2, 3, 4, 5, 6 groups around the central atom. All 6 are bonding, 0 are lone pair. Let's go ahead and let's take a look at the chart down here. So we're down here now. If we have 6 bonding, 0 lone pair, we are octahedral shape. Okay, so let's go ahead and write the shape name down. Octahedral. And let's go ahead and drag in the picture so you can kind of see what it looks like right there. Okay, that is the octahedral shape. Let's take a look at example number 6 now, AsI5 with a -2 charge. Alright, so let's see, we have the As in the center, and we are going to bond 5 iodines around the central atom. And let's go ahead and let's take a look at how many valence electrons we are going to need. All right, we have this is going to have 5 plus 7 times 5. That gives me 40. So I have 40 so far, but I have to account for this 2 right here. So I have to add 2 more in there, and I'm going to get 42 valence electrons. All right, so what I'm going to do is I'm going to go ahead and hit pause in just a second and fill in these electrons. So each iodine is going to need 6 more dots. So I'm going to go ahead and hit pause and fill them in. When I come back, it'll be all complete. Okay, I'm back and I have my Lewis structure complete. Let's take a look to see check our valence number of electrons. All right, so I'm supposed to have 42, and I have 1, 2, 3, 4, 5, 6, 7, 8 times 1, 2, 3, 4, 5. That gives me 40. I need 2 more electrons, so I'm going to place them around the central atom. All right, there we go. Let's go ahead and let's count how many groups we have. We have 1, 2, 3, 4, 5, 6. We have 6 groups. 5 of them are going to be bonding. 1 is going to be a lone pair. And let's take a look at what we have right here. So if we have 5 bonding, 1 lone pair, this is going to be square pyramidal. So that is our shape. Square pyramidal. And what's kind of neat about this is just think about it looks like a square based pyramid with the lone pair at the bottom. This is kind of what it looks like. So that is square pyramid. Alright, and lastly we have this example right here. Now you're probably looking at this a little bit funny, as you're probably thinking, well, I've never seen a molecule yet with xenon, and because that's a noble gas. And you're probably thinking, I thought you said noble gases can't react with anything. Yes, that's true except for xenon. Very, very few compounds have been able to be formed with it and fluorine. Alright, and xenon is an exception. Alright, so we're going to place xenon in the center, and we're going to bond the 4 fluorines around it. Okay, and let's go ahead and let's count up our valence electrons. So xenon has 8, plus each fluorine is 7, but there are 4 of them. So I'm going to say 8 plus 28, that's going to give me 36. So I have 36 valence electrons in this molecule. So I'm going to go ahead and fill these in, and let's go ahead and let's count these up. Alright, so right now, as I'm counting these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. I only have 32. So what do we do when we need extra? Just add lone pairs to the central atom. So let's go ahead and just do that. So we have 33, 34, 35, and 36. So I actually had to add 2 sets of lone pairs to this. So let's go ahead and let's take a look at what our shape is going to be. So I have 1, 2, 3, 4, 5, 6. So again, I have 6 groups around the central atom. 4 are bonds, 1, 2, 3, 4, and 2, right, these 2 on top and the bottom, are lone pairs. So let's go ahead and let's take a look at our VSEPR chart right here. So if you have 4 bonds, 2 lone pairs, you are going to be square planar. And the reason why it's called planar is because it's flat. And let's take a look right here, and it just basically looks like a flat square with two lone pairs on the top and on the bottom. All right, and that's it for VSEPR. So if you have any questions, please make sure you ask Mr. Kleinschmidt or myself. We'll be more than happy to assist you. Remember, stay for RST after school every Tuesday and Thursday. Bye.